and I just thought to say a couple of words about this series of distinguished lectures. So we started this in 2012, and the idea was and still is that we invite a couple of distinguished speakers in a year to give an invited talk, real world-class academics, scientific top-level people, but not only scientifically impactful people, but people, the series I think is called, this is a distinguished lectures in future information technologies. So people who have like some kind of a vision of where we are going. Because of COVID, everything was killed a few years ago. So the last lecture, I believe, was in 2021, and that was remotely even, but this concept didn't exactly work. So we are now starting to revive this physical on-site series, and this year we have at least 2 of this type of distinguished talks, and the first one is given today, but I let Giulio, who is the local host, to introduce the speaker.
Thank you so much, Petri, and also Professor Heikki Mannila is here, director of the series. It's a really great welcome, everybody, also the ones entering now. I hope the flow will continue, and it's really for me a pleasure to welcome Professor Margaret Burnett from Oregon State University here. I've been following her work many years. And in particular, she's a distinguished professor at Oregon State University, but it has quite an interesting, let's say, career starting in the industry. One of the very first software engineer women at Procter & Gamble. But then also, I think after some degrees, eventually started actually to already found a research field which was about end-user software engineering, which she told me today in Europe, our movement in Europe, it's end-user development, so but which is, I guess, a really ambitious initiative to help normal people program, and I think, but then she worked on visual languages and was the main architect of visual languages also, and recently has been looking at explainability and AI, and also one of her big missions around the world is to teach how to make software development more inclusive, and she developed several techniques to take into account different type of groups with the different type of requirements, thinking about the gender mag, that's a catchy term for one of these methods. And I was myself listening to her talk, a keynote at IUI, and I was really I really liked the way she brought on examples from how people were being confronted with these new AI conversational tools, and I found these reports to be really insightful, and I thought would be very nice to listen to them again, possibly with some additional insights that you were able to write maybe in the last year, and so it's really fantastic to have you here, and I will now go and enjoy the talk. Thank you, Margaret.
Thank you, Giulio. I'm absolutely delighted to be here. I'm on sabbatical this year, and my sabbatical is a Change the World mission. So I'm here to recruit all of you. Please help me change the world in a good way, I hope, because it needs it. Okay, so here is this long, hairy title. So let's just tease it apart a little bit. So, oh, he forgot to mention, I sing too, as you'll soon see, mission. To enable mere mortals, well, diverse mere mortals, to assess an AI agent's goodness for their own needs. Okay, this sounds hard, right? Potentially mission impossible, right? This is where we sing all together now. Bum 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 bum. Okay? Okay, good. Excellent. All right then. Your mission, attendee, should you choose to accept it, is to do this thing, enable diverse mere mortals to assess an AI agent's goodness for their own needs. As always, should you or any of your Mission Impossible force be caught or killed, this season's IIT hosts at University of Helsinki and Aalto will disavow any knowledge of your actions. Okay, so what would we like mere mortals to be able to assess? Here's a question that some mere mortal might have. Should I use an agent to enable me to be a remote caregiver for my grandmother, or do I really need to move in with her instead? There might be reasons why it would be really hard for me to move in with her. Maybe she lives in another city. Maybe I have family constraints in a different city. I mean, there could be a lot of reasons why this might be very difficult. Should I buy semi-self-driving car X or semi-self-driving car Y, or stay entirely manual? How does a mere mortal decide this in a way, their life could depend on this decision. This is not just, just pick one. Will my kids become less smart over time if I let them use LLM-powered homework helpers? Can you see this picture? Cross-eyed? Click, 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 click. Has anybody seen their kids do this? Well, actually, my grandkids, but whatever. Will the privacy and security costs cause me or her or him fear, embarrassment, danger of doing any of these things? Will the outcome of my decision harm my life or someone else's? These are serious questions. And they're also business-oriented questions that people might be also needing to assess an AI for. Why is my loan stuck? What can I do to fix this? A small business owner. A single parent who wants a job that pays a higher wage than they make right now. Why doesn't the computer rank me higher for this job? I already do work just like that. What about this one? Is this Google Maps route safe for me? Do people here call the police on black people? Okay, these are serious, serious questions. And even if you don't care about the personal situation of all those people, there's actionable AI legislation emerging all over the world. Here is the USA's recent White House blueprint for AI, sadly not currently in favor, but it doesn't matter because all the other countries also have very similar legislation. That one says you should, as a Bill of Rights, you, a mere mortal, should have access to a person who can remedy problems that came out of the algorithms or the AI system that caused them. You should understand, you, mere mortals, should understand how and why it decides outcomes that affect you. You should have access to timely human consideration and remedy if an automated system fails or if it produces an error. So as computer scientists, we have to enable our products to do this stuff. As mere mortals, these are rights that sooner or later we'll have. Well, we aren't mere because we know a whole lot more about technology than most people. But we're mortals too, and we have kids too, and we have grandmas too. Okay, so what this says is we computer scientists have to build systems that feature understandability and actionability for ordinary users. Okay, this can't just be stuff that machine learning experts only can do. And here's some bad news. All the rest, I guess, was not bad news? I'm not sure. Anyway, but here's some bad news. I'm not going to show you how to answer any of these questions. But I'll point out 6 paths forward toward answering them and 1 path on how not to answer them. Let's start with the how not to answer them. What else can I automate? Can I automate this? How many of you in the audience are in some computer-oriented profession or studying? Okay, looks like all of you. Maybe all but one. Okay, so have you heard this question before? Have you asked this question before? Over and over and over again? How can I automate this? I think I know how to automate this. Somebody else saying, can't you automate this? Guess what? It's the wrong question. We've all been brought up on exactly that question. But the question we need to be asking now is the second one. How can I make a great human AI ecosystem? Because what human and AI together are is an ecosystem. If humans become complete idiots, then so will AI. Because where does AI get its data? From humans. So it's a cycle. If AI becomes a complete idiot, what happens to humans? We probably do a lot of stupid things too, because we rely a lot on AI, and a lot of times we need to. So it's an ecosystem. You can't abandon one side without abandoning both. So this picture here, this is the grand vision. This is the vision that we've all grown up with as computer people, that this is what we're going to have, is this great team between humans and machines. Okay, so what's wrong with the what else can I automate problem? Well, here's what it usually turns into. Big machine, little human. Okay? The what else can I automate problem actually picks something that seems automatable and moves that functionality out of the human brain into the computer's brain. And so then why would anybody do that? Well, the answer is always, tell me, you've heard it. What? So, yeah, and also so that humans can do other things, right? Okay, good. What other things? Well, lucky for us, we know the answer to this from history, because a lot of automation has been happening over the last 20, 30, 40 years. So what are these other things that take up our lives now that we now have more time for? Scrolling around. Yay! Phone alerts. Emails. Notifications. Okay, click, 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 right? So this is kind of a myth, so that humans can have more time for other things. It's not really a myth. It really happened. We do have time for those things, but we were always thinking that those would be other good things, not other tedious things. So what we've done is taken away some of the interesting problem solving that used to happen in people's heads, stuck it in machines so that humans can spend more time on tedious things. That's why it's the wrong question. And that's why instead, this is not an anti-automation talk, this is we have to build a good ecosystem where we have really good teams so good that if the power goes out and the AI fails for weeks, the humans can still function somehow. And if the humans all get sick, the AI can function for a while somehow. We need strong team members and a strong synergy. Another researcher, actually a group of researchers led by Conwell, who wrote this awesome Chi 25 paper that has virtue ethics somewhere in the title, puts it this way, says, we need to support human flourishing for all of this to hold up and be sustainable. And the way they put it was, how can we help humans live well with tech? Not just live with tech, but live well with tech. And since this talk is about AI, we'll just change it to how can we help humans live well with AI-powered tech. So Conwell's position is based on this thing that's called virtue ethics, and it's a branch of philosophy, but it's also closely aligned with a lot of different religions' teachings. And the idea here is that we would like tools, here AI-powered tools, to promote good human habits. So what are these? We computer scientists don't have to decide what they are because a lot of different ethicists and religious beings have decided what they are, and they all agree on certain things. So all of these religions and this philosophical branch prize things like dignity of the human person. Okay, we can all agree on that. That's not really a controversial value. The importance of family and community. The care of God's creations, including people, animals, nature, and the planet. Okay, these are all pretty much agreed upon, except by a few politicians. But okay, nobody accused them of being ethicists. Anyway. Okay, so now you've heard the path not forward. Let's go. Sorry, I just couldn't resist. Now the path forward. One way to go about trying to come upon a solution for mere mortals being able to assess an AI agent's goodness for their purposes is to stumble forward empirically. And that sounds ridiculous, but that's kind of the state that we find ourselves in many times, especially when we're at the beginning of a new sub-area. And so here is a story of that. And it started with no clear result, and it ended with effective explainable AI. So let me tell you how it went. We had a video game that was AI powered, and we were doing 4 different explanation types to see which one would work best. And the goal was that the humans could understand the agent. Whichever explanation helped them do that the best would be the winner. And so the way we measured that was how well the humans, the participants, could predict the agent's next move. And so each color in this graph is a different explanation type. You can see there are 4 colors. So at decision point 1, you can see that the orange explanation type is slightly ahead. And at decision point 2 and 3, they're all doing pretty well. And down here, they're all doing really terribly. And, you know, although the orange thing is sometimes way ahead, sometimes it's way behind. In other words, this is a mess. You know, you can't get anything out of this at all. This is the part of the story that goes, no clear results. Okay, we really didn't know what to do with this. So we said, okay, one thing we can tell for sure is that none of these is all that good. And then we said, okay, so we're trying to enable the human to understand this thing, and maybe the reason that they're having trouble understanding this thing is that the AI itself doesn't understand itself either. Because a lot of AI is just statistics. AI doesn't really have a story that it tells, a pattern. It just does statistics here and it does them there. And so if the AI has no coherent model, then how could we possibly expect humans to do that? And so we said, all right, let's give the AI model. And so we experimented with an approach called model-based AI. And so first what we did is we let the model train, and it learned, we let the AI train, and it learned a model. And then it made decisions according to that model it learned. And so the model was its own, shall we say, coherent theory of how things worked. And we represented the model as a decision tree, but keep in mind it was learned. It learned that model using something more complicated. So, all right, that's just, this little thing is the explanations version of that model. You'll just see it's a tree, and it blows up to a more detailed explanation. The results were promising, but still messy. But then we had another insight. Ta-da! Explanations so often are treated by computer scientists as objects. It's like, here, have an explanation. Okay, we're done. But in real life, explanations don't work that way. You know, if you go to a teacher and say, give me an explanation, the teacher doesn't just toss you something and leave. And so we said, you know, when we're trying to explain an AI to a person, what that really should be treated as is an education experience. Not trying to educate the user about all of AI or about principles of AI, but about that AI, that one agent. But it's still education, a very concrete form of education. And so if we think about it as an education experience, explaining AI, then we say, duh, let's look at what education specialists know about educating people and draw that into our way of explaining AI. So what might we learn from the field of education in explaining AI? Well, teachers know a lot of stuff. They know that education has learning goals. So what if our explanations also had learning goals? Not just, this makes sense to me, here you go, but have an actual learning goal. What is it exactly that we want humans to gain from that explanation? So, okay, that sounds good. Learning goals also suggest appropriate measures. So when a teacher says, my learning goal of this set of explanations and lectures and homeworks is that students will be able to add numbers by hand, then they also know how to measure whether the students have succeeded. They say, so I'll give them a test and give them some addition problems and see if they can add them up. That tells us as explanation XAI researchers, explainable AI researchers, how we should empirically measure the results of our explanations too, instead of just conjuring something up, okay? Something that directly relates to the learning goals of that explanation. There's another theory from education or practice called backward design. Do any of your professors know this? I didn't know it either up until just a couple of years ago when I started hanging around with an education specialist. Isn't it amazing how we professors are not actually taught the field of education? We're just taught our specialty area. Well, that's the same as all over the world. So I hung out with this education specialist, and she said, backward design. Yeah, this is so easy. So what you do is you start with the outcome, and then you say, okay, so I want my students to be able to add two numbers together. So then what activities should I do that will give them mastery of that skill? And what do I need to give them so that they can do those activities with any hope of succeeding? So you work your way backwards from the thing you want to accomplish, the learning goal, through the activities, through the resources and materials you give people. It's really common in the field of education. We could use that in explainable AI as well. There's more. The field of education has a lot to say. So educators know to adjust teaching to content, to adjust their teaching methods to content. So there's this stuff they call pedagogic content knowledge, PCK, which is how to, it combines your knowledge of the content as a professor with your knowledge of how to teach as an experienced educator. And it's not a union, it's like a merge. It's how to teach this content. And so educators adjust the way they teach to what they're teaching. And we could do that with explainable AI as well, not just some template that we're always going to use for all our explanations. Further, educators adjust their teaching to the who's that they're teaching to. They teach differently to people who maybe, all different kinds of humans, like all the humans that contributed to those things. And the reason they do that is that they know that no one explanation or no one teaching method is best for all humans. And that's pretty much what our no clear results was telling us too. None of these is perfect for everyone at all times. It took us a while to figure that out. So what that says is, let humans choose their own best explanation that best suits what they need at that moment, given their particular strengths and weaknesses and backgrounds, and don't force them into some mold or try to make them in a one-size-fits-all bucket, because it's not going to work. Educators also know to keep users active. So active learning is a very common thing in the field of education where people do hands-on learning, not just sitting there and listening at all times. Educators know how to teach processes. When we say, oh, we want to teach long division, here's a long division problem, do it. We don't do that. We tell them how to do it. Okay, we give them a process. In explainable AI, hardly anybody provides a process for users to figure out how to figure out what that explanation means. Idea. Let's do that. So back to the explanation system, but now we're in path number 3. We added something called RFI, After Action Review for AI. It's a process by which humans figure out what the explanation is telling them. So we realized after a while that when we were giving humans these different explanations of AI, not only were we asking them to spend the cognitive energy to, through our explanations, figure out what the AI was doing, we were also making them build their own process for doing that. So they had to figure out a strategy. We were giving them nothing, and then use that strategy to figure out the AI. It's a lot of work. So we said, we'll give you a strategy. And so we derived it from the U.S. Army's original after-action review, and it's really simple. And it works with any explanation system. So here's how it works. First, the facilitator, or if it's an explainable AI system, then the AI system. Oh, automatically going to sleep. Huh? No, I don't think so. Explains the rules and the agent's objectives, and then there's this inner loop where we ask the user to think about what's supposed to happen here, what did happen here, why did it happen, and would you let it decide this kind of decision on your own behalf, what should change. And so we do this at each important decision in the AI process. Doesn't have to be every decision, just, just the important ones. So let's see how this worked. Oh, okay, so remember, this works on any explanation system. I'm just going to show you an example in one. Oh, don't squint. I'll read it to you. I feel bad for your poor eyes. Don't squint. I'll read it to you. I promise. Okay, this little thing is a game. Those of you who have played what is this? Something. StarCraft. Yeah, that's what it is. Thank you. You can see I'm not a video game player. Yeah, we had a 2-lane StarCraft game that we had all this setting in. And then here is our massive explanation system. And what it really is states and transitions, and this is a transition explaining how this thing went to this thing, and here is the user's finger saying, this looks wrong to me, okay? And they did that because of the RFI stuff that we added on. And so whenever there was an important decision, they could bring this up, say, I think there's a problem here, and I'm definitely sure it's a problem, or maybe it's a problem, or no, never mind, it's not a problem at all. So they could do that. They explain what's the problem. Here they're saying the friendly AI is producing banelings at this stage. That's some StarCraft character. I don't think it's wise since the safety of, and they go on. And then it says, why did this problem happen? And they say, I think the friendly AI is not paying attention to the enemy AI. And they were right. Okay, and then what changes do you think should happen? Okay, so basically this is active learning. This is getting them engaged and getting them to think this out. And here up at the top, they had a way to label whatever it was they thought this problem was about. They didn't have to. There was no pre-invented list of labels. They could type in whatever they wanted. And this might be the most valuable piece of the whole thing we did, is this ability to label it. Okay, so how did this turn out? Statistically, it was amazing. Keep in mind, same explanations in both the people that had RFI and the people that did not. But the people that had it found significantly more of the AI's problems than those that did not. That's the recall. And they also made way fewer mistakes in saying something was a problem when it wasn't, or vice versa. So their precision was also significantly better. Remember, they all had the same explanations. The only difference is we gave them this process to go with their explanations in the green group. Okay, and one of the reasons we think it turned out so well is because of those labels, the power of abstraction. So by giving them those labels, we were gently encouraging them to abstract, to pattern match, to find things in common. And so what we found is that sometimes people use these labels in ways that didn't help them at all. So the line is no advantage, to the right of the line is advantageous, to the left of the line is made things worse. And if they used it to say things like, I don't know, it's the bug location, like these were all in row 4, that didn't help them a bit. But if instead they mentioned some sort of naive AI thing, like, I don't think the probability could possibly be that high, or I think it must not have enough data, or things, naive AI things like that, it really helped. Or counting in math, like, these numbers don't even add up right. Those really helped. Or domain concepts, like the one we just saw about, I don't think it's strategically wise to have this many banelings. All of those kinds of abstractions really helped their scores in precision and recall. Okay, so let's come back to education. A lot of you are probably familiar with Bloom's taxonomy. It has these 6 levels. So we evaluated this, the use of RFI using Bloom's taxonomy. And so at the very lowest level, here, the top row, just to confuse you, is just remembering stuff. And the most sophisticated level is being able to create, generalize, abstract using the thing. And then there are all these levels in between. So just to give an example, here's level 3, applying the information they learned. And here's one of the participants saying, I could try to draw my own conclusions from it. Okay, so we can see they are pretty capable of drawing their own conclusions, and it's not just them saying so. This corresponded to their scores in being able to get the AI right. Okay, let's move on. Inclusiveness. So let's imagine product G3. And this product has some before and after results. So some product manager who owns G3 said, okay, it's not working out very well. We're going to redesign it. And they do. And then they run a study. And here is 0 improvement way over here on the left side. And then all these bars are saying, hey, there's some improvement. And yay, it got better. The product manager should be very happy. And all these little stars actually were significant. And nothing got worse. So all of this is good. But look at all this room for improvement. I mean, yeah, stuff got better, but not that much better. Okay? Wouldn't it be nice if the product could do even better? But how to begin? And so the product owner asks, okay, who was included in these gains and who was not? Well, so the difference between these two products is that one of them followed a set of guidelines for human-AI interaction. These guidelines came from Salima Amershi and a bunch of her colleagues, and one of them, guideline 3, was time services based on the context. So this is a guideline that they devised using very responsible methods, and so G3, the old version, did not follow that guideline, and the new version did. And that was the only difference in G3, is without the guideline, with the guideline. So good, we can see it helped. But we'd like to know who was left out. So what we decided to do is compare the one that was left out, the old version with the new version, on some nice human-oriented variables, and also find out about all the participants' problem-solving styles using the GenderMag survey. GenderMag is a gender inclusiveness magnifying method, and we're not going to go into a lot of detail here, although advertisement, if you want to learn how to use GenderMag, you could come to the Alto campus on Wednesday from 9 to 12, and learn how, hands-on. Originally, Julio and I announced that you had to apply for it, but we didn't get all that many sign-ups, so you don't have to apply, just let him know. It's Wednesday at the Alto campus, 9 to 12. Okay, anyway, but these 5 problem-solving styles are self-efficacy, which is a specific form of self-confidence, motivations, someone's learning style, someone's information processing style, and their attitude toward risk with technology. Anyway, we have a validated survey that measures people's attitudes and feelings about those problem-solving styles, so we gave it to all the participants. So now we knew all of those, and there's a teensy little copy of the survey, but don't worry, you can get the paper on Google Scholar if you want to, so please don't squint. And then all you do is you test the half of each style against the other half. So you test the risk-averse and how well they were feeling about the product against the risk-tolerant. You test the comprehensive information processing people against the selective information processing people. And what you find out is who was left out of the gains from G3. By the way, we also have a socioeconomic MAG survey, just so you know. Okay, and here is what 3 questions in the survey look like. These are the questions about people's attitudes toward risk. I avoid advanced buttons or sections in some type of technology, AI-powered PowerPoint, I don't know. I avoid activities that are dangerous or risky. Despite the risks, I use features in whatever that haven't been proven to work yet. Okay, so this measures people's attitude towards risk. There is no right answer or wrong answer. It just reflects the way that person works. Okay, so here we are. And the A's are the people who answered risk-aversely, and the T's are the people who answered risk-tolerantly. And so what we can see is that when there's nothing here at all, it means the product did not improve for anybody in their feelings of control. Here, since we've been interested in G3, G3, well, let's stick with this whole thing. You can see that feelings of control, actually, that got better for both the risk-averse and the risk-tolerant. So whatever it is they did there, that was a good thing. But you can also see on a lot of these things, the improvements only helped the risk-tolerant, kind of left the risk-averse behind. So that's telling you who was left out of a lot of attributes of what they did to product G3. All right, now, one more thing on that slide. You can also see that when they tested G1, applying the guideline versus not applying the guideline, that was kind of a wasted effort. No gains for pretty much anybody. On the other hand, this middle batch, these were awesome. Okay, those guidelines were super effective. All right, so back to G3. This is just a detailed view of what that looks like. I think I'll skip that. Anyway, when we did all of those evaluations, we came up with some really valuable insights into how human interaction can be affected by some of the choices. The first thing was user control mattered hugely for both risk groups. Most of the inclusivity gains in all of these products came about with increasing users' control over every decision, every step of the way. Learning from my data mattered. So everybody says, oh, yay, AI, yay, I'm so happy, it's going to learn from all this data. Wait, not my data. all of you people, that's fine, but not my data. So pretty much everybody felt that way, especially the risk averse. So when it became clear to them that the AI was watching their data, they felt very creeped out, and they did not like the system a bit. These risk results, and this is just risk results alone, were very actionable. So by finding out who got left out, we also found out why they got left out. And when we find out why they got left out, we know what to change. So for example, with user control, the answer is obvious. If you know that users want more control, give them more control. Okay, allow them to say, store my data, yes or no, things like that. Turns out that these results also help explain demographic differences. So if what you want is to serve more customers better with AI-powered things, then you don't really have to look at demographics, at which gender or genders do like, don't like your particular product, which age groups. If you just look at problem-solving styles, you have something actionable, because what you want to do is support an entire spectrum of, say, for example, attitudes toward risk, not just the risk averse, not just the risk tolerant, not just somebody in the middle, but the whole range. And the way you do that is you just take down a barrier that was in the way of the risk averse, or take down a barrier that was in the way of the risk tolerant. Just get it out of the way like it was a bug, okay? And now you've got a wider range of people supported. Okay, so let's come back to these questions. Why is my loan stuck? What can I do to fix this? Why doesn't it rank me higher for this job? I already do work like that. Is Google Maps route safe for me? Do residents here call the police on black people? It turns out that AI has gender inclusivity bugs. And an example is simply not supporting one of these problem-solving styles. Here's somebody worrying about that. They say, you're kidding, where? This person's a busy software developer, and the answer is in the AI you create and in the tools you use to do it. And this person says, how? And as I've already shown you, gender clusters in the way people problem solve. And this person is worrying, does this really matter? And the answer is yes, big time. Because every time there's a barrier in the way someone problem solves with your technology, it's like a cognitive tax they have to pay. Now, what I just said had the word gender in it, but it's true with any demographic difference you want to insert. So we've also been doing work on socioeconomic differences. They, again, cluster around certain problem-solving styles, statistically, of course. And so everything I just said about gender inclusivity bugs is also true of socioeconomic inclusivity bugs. And if you drop in age instead, it will also be true for age inclusivity bugs. It all comes down to problem-solving styles. If you support a diverse, wide ranges of problem-solving styles, a lot of these things just go away. Okay, so then what you might say is, well, how do I do that? Do I have to have a separate version for each age group, each gender, whatever? And the answer is no, because the world doesn't divide up into groups. There's no such thing as a typical anything, a typical 50-year-old or a typical woman or a typical anything. So we don't think about dividing the world up. We think about debugging problems in our software by taking down the barriers one at a time. So to debug, use inclusive design methods, gender mag, socioeconomic mag, age mag, all kinds of other mags. let's see here. I think I'm going to get right to the crux here. To enable, so the conclusion was to enable diverse mere mortals to assess an AI agent's goodness for their own needs. Here were some of these questions. Should I use an agent to enable me to be a remote caregiver for my grandmother? Should I buy a self-driving car? Which kind? Will my kids become less smart if I let them use LLM-powered homework helpers? What about the privacy and security implications of all of those things? Will it harm my life or someone else's? But I've shown you a lot of ways that we can move forward with this. And one thing we need to be sure of is that we need to make sure that our agents are understandable and transparent and honest and not sneaky, the truth, the whole truth, inclusive to differing ways of thinking and differing concerns. So I gave some paths to do that. And what the path isn't is what else can I automate? And what it is how can I make a great human AI team where everybody thrives? So I gave 6 paths, including stumbling forward empirically, drawing from the field of education, adding RFI, the after action review method, to any XAI or assessment product, measure inclusiveness, which gives you actionable whys on how you can make AI work better for everybody. Use some member of the Inclusive Mag family or build your own member of it. Oh yay, I forgot all those pictures. So, is enabling diverse mere mortals to assess an AI for their own needs mission impossible? No, it's mission challenging research ahead. These things are not impossible, but we have to put our minds to it. It's not trivial, okay? Fortunately, this is a room full of researchers. That's what we do. So it's really a critical mission to deliver all these properties because we really need smarter, not dumber human beings who can flourish with AI tech, and a stronger, more resilient human AI ecosystem. If you want to talk more to me about this, that's why I'm here. So you can see me after this talk. I'll just kind of hang around here. And on Tuesday and Friday, I will be in A321 in the Exactum building from 9 to 3, 9 to 15. And Wednesday, you can learn the Gender Mag method, 9 to 12, at the Alto campus in some room. Klondike in, what was the rest of it? Dibblee. Okay. And Thursday, I'll be at the Tampere campus doing an advanced talk on inclusive design hosted by Kaisa Vannanen, so you could contact her if you want to. So yeah, please come visit with me. I'm very interested in joining together with anybody who wants to help me change the world. Oh, wait. Oh, shoot. I forgot. Wait. These, okay. Okay, now it's really done.
So it's not possible to have the slides now, somebody asked. Thank you so much for this. I'm very happy that we get a few minutes to reflect on this talk. And I wanted to start myself, bridging, but then I'll try to make this brief because usually when I start to talk, I make it too long. But I really want to give a floor to all that made it an effort to come here. But I think this is important. In 2022, we hosted the IUI conference, the Intelligent User Interfaces Conference in Helsinki, but we were online. And we invited as a keynote speaker at the end of the conference, Stuart Russell. And he had a talk about how we have to think differently about assessing AI. And his proposal was that you can all read about and actually watch the talk on YouTube, is provably beneficial AI. And his point was that instead of trying to get AI to optimize on one particular objective, we should recognize that AI is uncertain of what the objectives should be, and that the part of the objectives are determined by how beneficial the AI is to us. So, but he moves from a quite different approach, which I would characterize, and possibly I even asked ChatGPT what he thinks about these two positions, that his approach is more top-down. That you try to recognize that AI needs to have, let's say, handle this uncertainty about the objectives and understand when something is beneficial or not. But his proposal, like it's, I would say, tradition in many of thinkers, AI thinkers, is that you can actually formally do this through formal methods and make sure that AI does these checks. Whereas, but anyway, that's provably you. Instead, your approach is very bottom up, and something it resonates with my research a lot because I'm very much in the field a lot, and I feel the call of the jungle of the field all the time. So my problem, while I kind of see both approaches, and I think that there should be, there could be more bridges built between some of these positions. But some of the issues I have now in doing my research is that everything changes so fast that usually I would have a whole year to have a whole development cycle with analysis and everything. But now let's say we wrote a paper, it was rejected, it's old already. I cannot repurpose it anywhere. And so the bottom-up process of how do we do a lot of this path needs to take into account that things are developing so fast. And even if I do a study now of how people use ChatGPT, is it still, valid in a few months from now? And then to everybody else.
So I guess I'm a huge believer in checks and balances. I don't like to give all the power to a mathematical proving person, even if they're really smart. And I don't like to give all the power to the CEO. And I don't like to give all the power to the individuals in the street either. What I like is for all of those people to have voices so that no one person can become too stupid for too long without the other people saying, wait a minute, you don't get to do that. And so in the AI world, a way to achieve that is to give the people who are, not just the people who are using it in the field, but also the people who are having their lives decided by it, and they never even got to use it. People whose loans got denied, they never got anywhere near a computer, but they were still affected by it. To give all of those people controls, but not the only controls. There are some things that mere mortals don't know, that, the people at the top do know, because they're much more highly trained and educated, but on the other hand, they don't necessarily have all of the knowledge of everything that is affecting all these people out there. So no, I wouldn't be in favor of either approach alone. I think it should all be balancing each other. Please ask me questions. The harder, the better. Nasty questions appreciated. Oh, good. When I said that, are you a nasty person?
Can I throw this? So I hope I don't kill Anders.
Oh, yay.
All right,
I'm
does
so
this work?
impressed.
You were saying that in the end it doesn't really matter about clustering by gender or socioeconomic status or age, because it's just down to the different types of problem solving. But then why is there separate gender mark, SES mark, age mark? What's still different?
Okay, why are they named those things? Okay.
And what's the differences between them, actually?
Oh, okay. So it's a really good question. Let me repeat it. So she said, okay, so you've really said it's not really about demographic distinctions at all, like gender or socioeconomic, because she points out that I said it's really about factors that affect people's problem solving when they're around technology, and she's right. So there's this family of methods called Inclusive Mag. And I kind of skipped over that slide, but I will show you a little dab of it. It's this diagram at the bottom, which, let's see, if I escape out of that, I can make it bigger. But then you can't see it, so never mind. Okay, that was a bad idea. Wait, maybe I can. There it is. Now I made it bigger. Go there. There. Okay, so I didn't do it perfectly even yet. But at the very beginning of it, oh gosh, I'm going to have to do it perfectly. At the very beginning of it, what the, goodness, where did it go? This is so weird. I've got it selected and I can't get to it. There. At the very beginning, what the inclusivity researcher does is they say, I would like to make something, let's say, more gender inclusive. And so they select a diversity dimension. And then they begin a bunch of research and analysis that ultimately produces problem-solving styles in which there are big gender differences. Why gender? Because they've chosen that as the area of particular interest to them. And so a student of mine, a PhD student a long time ago, began in exactly that way. And she ended up with, 17 different problem-solving ranges. But we wanted something practical. And so you can't give a user experience a checklist of, you've got to support all 17 of these ranges. It's like their head would break. So we picked the 5 most statistically different among the different genders and most thoroughly established by all this foundational research all over the place in other fields. And then we took those 5 into the lab and verified them ourselves on other software to be sure we could really believe those. And so that's the long answer to saying it could have been any problem-solving style, but we were optimizing to bring about more gender inclusiveness. And so then we went about it the same way for socioeconomic inclusiveness, but this time we were optimizing on factors that particularly affect differences in how somebody's socioeconomic identity affects the way they interact with problem-solving situations on computers. And some researchers in Australia did the same thing, but they were interested in age differences. So all of these are really just optimizations to keep things practical for whatever demographic some company or some department knows they're really in trouble with. But it never does any harm to use, say, gender mag if what you really cared about was age. It's not optimized, but it can never do any harm to take down barriers that are affecting someone. So, long answer to a short question. I'm glad you asked me a hard one, though. Yes. Ooh, she's trying for harder.
Thank you, and thank you very much for this really interesting and also practical talk about the theory and your research behind it. I was curious about the scaffolding in the game context. How did you go about deciding which abstractions to scaffold?
Okay, so this is back on that slide that was talking about the wonderful power of abstraction that these users, let's see, can I go that way? You can't believe how strange the thing is that I'm looking at on my computer right now. Wait, there, okay, there it is. This is what you're talking about, right? Where the people who abstracted around domain concept, okay. So the question was, how did you choose which abstractions to give them? And the answer is we didn't. They chose. So what they did Sorry. Let's see, I think this is the slide. What they did is type in anything they wanted, free text. And then what we did was qualitatively code what kind of stuff they put in. And so this one we coded as domain-oriented because it was about the game. And it turned out on that next graph that domain concepts were very helpful in them really understanding what was going on. That answers what you were asking?
Yes, thank you. Yep.
Okay. Behind you.
Sorry. Can I short question? Hi, Jussi Wright. Can you please put one slide back, I think? That one. Was that kind of online that the eye model was going inside through those questions to evaluating or labeling, or was it like, yeah, so...
Yeah, it was. This was a COVID-era study, so I'm not going to explain what we did given that it was COVID, but I'll tell you what we would have done if it weren't COVID. So we started with a qualitative study and then a quantitative. And the qualitative study, the idea was to spread, spread explanations like this. There was this huge number of them. We were going to print them out on this gigantic piece of paper and spread it out all over the conference room. And we were going to give them a laptop where they could interactively play the game as well, and give them a clipboard with these questions on it, and have them just walk around the table and write stuff and make notes and do whatever they wanted, so that we just wanted to give them just all this unstructured stuff to see how they would work it out. And then we would build our system in a more informed way based on what we saw them do. Well, we did a kind of equivalent of that on COVID. And it worked out really well. It surprised us we could do anything during COVID, but we did. And then the lab study, the controlled statistical lab study, we did that on COVID too. Lord, that was hard work. But it came out clean, and our results were really, surprisingly clean. We wrote a little paper about the way we pulled all that off. But anyway, yeah.
Thank you.
Were you? Let's see how good your catching skills are. Oh, I'm so impressed.
Yeah, the throw was so good. It was easy for me. Thank you so much. I really like the idea of human AI ecosystems or ecologies as a sort of starting point. So I'm building on that. I'm also curious, since in an ecology, what's relevant is not so much the individuals, but the relationships. Those are kind of central, you could argue. So how that could be taken into consideration here, like people, also the sort of human-to-human relationships. I'm also thinking I'm super excited about the work of someone called Vanessa Andreotti, who is Dean of Education at the University of Victoria. And they have been doing work with something that they call meta-relational AI, which is basically an AI agent trained based on what they call a meta-relational ontology. I just wanted to bring that up. We're bringing her to Finland in September because we're really excited about this work that she's doing, and it takes a really bold and very different sort of approach to not so much understanding how this thing works, but instead sort of leaning towards what they call epistemic humility. Like, since it's an emergent intelligence, like how can we, maybe it's not our task to try to understand it, maybe there's another way. So this is it's not a question so much as something I just wanted to share, because I would love to see more smart people look into the work that they are doing as well, and somehow contrast it to what we've heard here today.
Yeah, I'm very interested. I'm Burnett at OregonState.edu. I hope you'll forward a reference.
I promise to do so.
Wonderful, thank you.
And they have a website called metarelational.ai if anyone wants to check out the sort of training methodology and the philosophy behind it.
Wonderful.
Yes, all right.
Okay.
Thanks a lot.
All right. So, do we still have one question? Oh, wonderful. Yes.
Yeah, about those questions in the beginning, you said you are not going to answer them. So which one is the hardest?
Let's see.
Should we vote?
Which one is the hardest?
Or easiest?
Well, I'll tell you the easiest question to answer is the blue one, the dark blue one. The answer is yes. That's easy to answer. Not so easy to solve, but very easy to answer. Yes, my kids will become less smart over time if I let them use LLM-powered homework helpers. And those of you who have kids maybe already have seen that. Yeah? Have you? No? Really? Yeah, are you nodding? You've seen it? Okay. Okay. This is just to prove I'm not crazy. Okay. He has proven it. Ooh. He has proven I'm not crazy. Yeah. Okay. Just like the proofs. Which one is easiest to solve? Or hardest? Well, I guess I mean, it's easy to answer bottom three, really, or at least these two. That's a yes, and that's a yes, the yellow one. I mean, we've seen this already. We've seen privacy and security costs causing people fear, embarrassment, and danger. I mean, the news, just read some news and you'll find that. Solving it, I would say the yellow might be the lowest hanging fruit, but none of these are that easy. I guess the brownish one might be the easiest because it seems somehow a little bit more constrained, somehow a little, and besides that, there's always a do no harm thing there, which is staying entirely manual, which is somehow the safe road for most people. I am really unable to do better than what I just fumbled around doing. Do you have an opinion?
That's good. That's good for me. So.
The manual car. Yeah, I'm on board. I'm still driving a stick shift. Yeah.
I don't even have an automatic gear. So.
Okay. Anything else?
Okay.
Okay. I'll be around
Yeah.
if anybody wants to chat.
Okay,
And
if you'd like some time this week with Margaret, please come here. We'll arrange something. I would like to leave with the most difficult question I can think of, but you don't have to answer. It's a bit borderline philosophic. There was a whistleblower, a Meta whistleblower, a few weeks ago, that discussed how Instagram was sharing data about teenagers to identify when they are most vulnerable, and then sharing this data with advertisers. And you could think that this is an extreme case of, trying to satisfy a need. From that point of view, the objective is to give to some person something that satisfies some need. So from how with thinking of this very ugly negative example, but it's still describing some objective to be maximized. How does, for example, one of your mags on age, how would it make sure that, let's say, the design would be to the benefit of whom? how do we deal with this kind of situations where we are developing something, we are maximizing some objective, but then is it a beneficial one? Is it a good objective or not?
So if I were if I were using a mag for this, let's say we had a mag that was teens versus adults. So we'll call it teenager mag. Or maybe teens versus parents. We'll call that one teenager mag. And so if we had such a mag, first of all, it can never ensure. It's not a proof system. So none of these mags is ever going to achieve perfection, but it's going to make things better. So that's all we can hope for. Anyway, if we used one of these mags, we're going to call it teenager mag, we would have two personas, and one would represent attitudes that affect the teenagers' desire to use technology and the way they go about using technology, and the other would affect the parents' thoughts, problem-solving views, problem-solving styles as it relates to their teenagers' use of technology. And so in both cases, we would walk through the thing that the system does, but we would assume that the system was being transparent about what it was saving, so at least everybody knows the issue. If it's not, if it's doing it under the hood secretly, then there's nothing any of these mags are going to find, but we're going to assume it's transparent. So then if we walk through it from the teenager's perspective and we say, okay, you know, the system has now determined you're more vulnerable and we're going to send your stuff to clothing stores, you know, then some teens might be risk tolerant and they might say, okay, fine. And other teens might be more risk averse and they might say, ooh, this is creepy. So we would catch that. Then if we did it again from the parent's perspective, I would think that most parents are going to be more risk averse about all of this. And so when we get to that stage, I think a lot of parents are going to come down and say, no, I don't want this. So that's how we would find those things. Now, whether the company would then fix them, the way these mags work is we have an inclusivity bug report. And so they write down these problems just as you would write down any kind of bugs, file them just like you would any kind of bug report, and then it's up to the development team to put them in their bug tracking system and prioritize them however they do. So we don't know what would happen to that afterwards, but I think they would catch them.
Thank you so much, Margaret, for this lesson. Thank you all, and thank you for making it here, and hope to see you in some future other distinguished talk. Thank you.